Brain metabolism. The adult human brain weighs approximately 1.5 kilograms. And approximately 100 billion neurons and 900 billion glial cells make up the organ. So blood supply to the brain is approximately 750 mL per minute, or 50 mL of blood per minute per 100 grams. If you compare to 2.2 to 5 mL per minute per 100 grams and 50 mL per minute per 100 grams for skeletal muscle. So when you're resting, your skeletal muscle only takes 2 to 5 mL per minute per 100 grams of tissue. If you exercise vigorously, you can increase the blood flow to the muscle more than 10 times. So here it goes from 2 to 5 to 50 mL per minute per 100 grams. So what I'm trying to just give you a sense of how much more blood flow you have in your brain. And this is, again, regardless of whatever you're doing. This is a constant blood flow that is maintained in your brain. So to maintain its high metabolic rate, the brain oxidizes approximately 120 grams of glucose per day, or 20% of your whole body energy consumption. So this calculation, this estimation, is used for people to say, well, this is why you should not eat less than 120 grams of carbohydrate per day. But this is, again, if you completely ignore that your body can make glucose. Because there's a lot of people who eat way less than that, and they are absolutely fine. So this calculation is based on what this typical diet that we have, which is rich in carbohydrates. But 120 grams is the estimate that would be required per day to supply your brain function. Now, the blood-brain barrier, as I mentioned, prevents the access of lipid-soluble molecules to the brain. Again, because it's very tight, doesn't allow bigger molecules to cross, it has to be small. So thus, it essentially relies on glucose for its energy supply. Glucose is mostly oxidized, and a small portion is released as lactate. So your brain does mostly aerobic metabolism all the time. Just a small amount turns out as lactate. So this also means that your brain requires relatively high rate of oxygen consumption. And this is crucial. You have to maintain blood flow to your brain because it's not only the sugar that matters. Actually, what is more important here is the supply of oxygen. Because if your body is going to process any kind of substrate, be it glucose or ketones, for instance, it needs oxygen because it has to be through oxidative metabolism. So high rate of oxygen consumption. And as I mentioned before, under prolonged starvation or nutritional ketosis, the brain adapts to use ketones. And the thing with ketones also is that it has a satiation effect. If you fast and you are not used to doing it, it turns out that once you stop eating for a little while, you're going to get hungry. But then if you persist, if you don't give in to the hunger and you keep fasting, it's going to come to a point that you're not going to feel hungry anymore, or at least for a while. Why is this? Because that is the time that takes for your body to release ketones. Ketones get into your brain, and then it signals to the brain satiety. So it activates areas in your brain that stimulate satiety. So you don't feel hungry. So again, if you do it for a while, and as time goes by, you're going to see that these adaptations take place. This is because, again, your brain will adapt to using ketones. Glucose enters the brain via GLUT3 in the neurons, and again, GLUT1 in the blood-brain barrier. insulin is not required for these transporters to operate. They are always sitting there, no matter if you have or not insulin, they are going to do the job regardless. GLUT3 and GLUT1 are saturated with substrate and normal glycemia. What does it mean? It means that under normal blood glucose levels, which is approximately 5.5 millimolar, those glucose transporters, they are working at maximum capacity. So this is important because if there are variations in glycemia, it won't change much the uptake of glucose to the brain. So you don't have oscillations in how much your brain can, or the supply of glucose to your brain does not change much because those transporters, when you have relatively low amounts of glucose, they already work at their maximum capacity. So they keep pumping glucose into the structure. It's not until glycemia falls below 2 millimoles per liter. So you have to really have very low blood glucose levels that then these glucose transporters are not going to be able to supply all the glucose that has because the amount that arrives to the brain is very small. So hypoglycemia means that you have very low blood glucose levels and that can affect your brain function. Not common. Most people, they never experience this because blood glucose levels very rarely drop below this number or at this low because your liver pumps out glucose and keeps maintaining it. But there could be some situations where your liver cannot keep up with the demand for glucose and it might interfere, you might develop hypoglycemia. We have seen this in rare cases, but it's possible when people exercise. If they do very prolonged exercise and they don't take in any glucose or they run out of the glycogen in the muscle, and if they try to exercise at a high intensity that demands high glucose in your muscles, it may drop your blood glucose levels. Very rare. You almost don't see it these days, but it's possible to occur. Another situation where hypoglycemia becomes a major issue is with type 1 diabetic patients. We learned that type 1 diabetic patients, they have an autoimmune disease that destroys their beta cell. So if it destroys your beta cell, you don't produce insulin. So the people develop most often, first, hyperglycemia. And hyperglycemia can be deadly if not treated. So what happens is that if you develop hyperglycemia and you have complications associated to that, you go to the hospital and you didn't know, but you have type 1 diabetes. So they start giving you insulin. So the challenge with a type 1 diabetic patient is not so much it's not the issue of having to deal with injecting insulin. It's how to match insulin with carbohydrate. Because now you are supposed to mimic what your body does. When glucose goes up, insulin is released, so it regulates your blood glucose level. That's what happens in normal people. But in a type 1 diabetic, because you don't have insulin being produced by the pancreas, you're going to have to use exogenous. You have to inject from outside. So when you inject outside, you have to be able to match insulin with carbohydrate because there is a certain number of units of insulin that clear a certain number of units of glucose. So if you don't match it reasonably well, you're going to either have too little insulin, glucose is going to go up, or you're going to have too much insulin and glucose is going to go down. So that's when you can see, and this is one issue with type 1 diabetics, they have to be very careful because if they don't match properly, if they don't manage well the carbohydrate insulin dosage, they might develop hypoglycemia, and depending on the condition, they may pass out. Especially when they're sleeping. That's why there's a big concern with what they call nocturnal hypoglycemia in type 1 diabetics. go to bed, they inject, let's say they had a carbohydrate meal, they inject some insulin, they sleep overnight. When they're sleeping during the night, if the carbohydrate or if the glucose levels drop too much because there was an imbalance between insulin and glucose when they went to bed, they might not even wake up again. Because if glucose level is too low, too long, the brain doesn't function anymore and the person may die. So there are some cases where type 1 diabetic patients die because of this mismatch between how much insulin and carbohydrate they used before they went to bed. And there is another complicating factor is when you add exercise on top of it. Because as you put them to exercise, we know that exercise increases the uptake of glucose in the cells, in the muscles. And this is independent of insulin. Now, if you exercise and you inject insulin, you're going to maximize the uptake of glucose, you're going to potentiate the effect, and that may precipitate hypoglycemia. So all these little things make sometimes very challenging for a type 1 diabetic patient to really match this different dosage of insulin, carbohydrate, exercise, and some other issues that may also affect glycemic control. So, but in the normal circumstances, your blood glucose levels very rarely goes below this value or low enough to make you feel hypoglycemic or to have any complications associated with that. The main concern is with type 1 diabetic patients or anyone who uses insulin for any purpose.